Hey everyone, this is Ricardo Billazar, Lessons with Ricardo, and today we're covering VLANs. Yes, if you're not aware, we're going to cover the concept as well as a walkthrough on the product I use, the UDMP. Now, if you don't have this product, no worries. We'll have more videos in the future on PFSense and OpenWRT, but the most important part is to look at the concept, so we'll cover that today. All right, let's jump into it. All right, so first things first, we're going to jump into the program I use, which is Draw.io. As stated in the previous video, it is a free product. So if you have access to a machine, I run Linux, but if you have access to a machine that can also have this program, it's not bad to have on hand to draw out diagramming for your network, logical or physical. All right, let's go ahead and get into the logical diagram we're doing today. We're dealing with virtual local area networks. And I think the best way to teach anyone the concept is to draw it out. So let's go and jump into the program. We got on here, I'm going to start as normal with our clouds. So the cloud is going to represent our virtual network. Well, let's say it this way. It's going to represent our home network, okay? So let me get that resized just a little bit here. So this is everyone's home network. So let's first talk about what a VLAN is. It's a segmentation. It's a virtual local area network. So it takes your original local area network, which is a standard IP addressing, internal IP addressing, I should say, of 192.168, and then normally the next octet, which is the next number after the period, is going to be a 1. It could be a 0, depending on how your vendor set it up. But that's your standard layout. A VLAN allows us to segment that into multiple other networks without having multiple switches or multiple devices to do so. So it saves everyone that does this a lot of money in hardware, but more than that, it brings to the average person the option of increased security by separating one network from another. We will get into another topic coming up, though, where we discuss, I guess it would be called trunking in a sense, that allows one network to talk to another, even with VLANs. Now, that's really important to understand from a security standpoint because that is, I think it goes against the point of setting up VLAN sometimes, and not every vendor has this enabled by default, but some do, such as the product I have, which is Unifi Dream Machine Pro. That product, if you create a VLAN, just normally it will be allowed to talk to other VLANs, which really doesn't give you much segmentation. Really, it just gives you a new set of IP address numbers. That's kind of a rundown what we're looking for here. So I'm going to throw up here just to show you segment wise. Now, of course, sizing is up. I would do that. Let's go and drag the line up here. And I want to rotate, but I don't think I can rotate. So I'm just going to pivot and cut this up a little bit here. Let's go ahead and drag this over. Now, the only thing I don't like about this application is sometimes it gets a little wonky with making these lines. Let me go ahead and copy and paste. And I'm hoping this allows me, I knew it. Every time I try to do that. And it does not back that part. Okay, so let me try this way. Copy and paste again. Yay. All right, that works. So this is 2 VLANs at this point. Now, another line just went off. Okay, let's go and do it one more time. We'll do a no, I just want to click on here. Check that. Why are you doing this to me? Okay, there we go. All right, we got it. So now with this separation, this is just a visual aid for what we're going to end up with. So this is 1, 2, 3, and 4. And in fact, I'll just go ahead and double click. I'll add a text box. We'll call it VLAN 1. Now, some systems, like on my product, VLAN 1 is called default, the default VLAN. The name is actually default. And then you get to name different ones, but we're just using generic filler right now. So we're going to throw VLAN 2, and let me just see if I can just copy and paste, make this a lot faster, and then just edit. 3 and 4. There we go. So now we're moving into position. VLAN 4. Now it doesn't matter what order. This is just for the sake of the video. All right, so that's what we have. Maybe I'll just put it right here in the middle of the cloud. This is what we are shooting for today. And we will show you what I named mine, but that's kind of what we're shooting for. So this is the segmentation. So in theory, if trunking is not enabled, or let's just say it's not allowed that any VLAN can speak to another VLAN by default, then in essence, traffic from one area to another will not be able to pass. It will be blocked. So if I just put an arrow here, just to show that. Oh, that's why I hate that part. All right. So back and forth, it's going to be stopped. It won't allow for back and forth. But let me just drag it this way. This is what we want to make sure cannot happen. So that transfer of data, that's why I'm going to put a line here, kind of like an X. And apologies, it's just lined up for some reason right behind my camera. So we'll do that, enter. So that is 1, and we already have another one. We will switch this the opposite way. So we don't want this to happen. So we don't want the traffic to cross this border. That's what we're looking for. Block that out. Not need it. And I don't know how many of these little lines. There we go. All right, so there you go. That's what we're looking for. We don't want that to cross. This needs to be totally separate from each other. And let's give it an idea. So now that we have it laid out, like I said, default is 1. Let's say this is an IoT network. So IoT, Internet of Things. That's something like a refrigerator, a dishwasher. It could be any, like a webcam. Well, not webcam, I apologize. A security camera. Those qualify as IoTs. There's no reason to have those on the same network that you use your computer. So let me get rid of this because we already know what that was for. No need to have it anymore. So let's imagine we have, normally we would have like, where are the laptops? Let's say it's a tablet. With a tablet over here and mobile phones. You may want to separate your mobile phone. Maybe make this your mobile network, right? Now, the only problem I do want to say, in today's age, a lot of people like to stream from one device to another. When you set this up, that is part of the planning you want to take into consideration. What devices are going to be on each of these VLANs? So, for instance, let's say, once again, we're going to use a monitor. Let's say we want the monitor to represent the TV, because it's probably the only thing I have that makes sense. We'll move this over here. If I place this TV, once again TV, in the VLAN 1 or default VLAN, then mobile, this phone right here, cannot talk to it. It will be, it won't see it. It can't send any messages to it. There are ways around that, which we'll walk through as well. But for the most part, if you don't configure it any differently, it won't be able to talk to that. Therefore, streaming from your phone to your TV will not happen. So the reason why I say that is because when you create these networks, maybe decide on putting TVs and mobile devices on the same network so that you can still stream and have your computers in a different one, computers and tablet in a different one. That's the idea, right? So I like this one. So let's put this. This is a virtual machine, but we'll say it represents the laptop. Oh, here's a laptop. I know, I'm just being picky. All right, there. And then IoT, I don't think I have any refrigerators, and I think they do have an IoT section. Let me see. Internet of Things. Oh, look at that. So I don't know what any of this means, but I think you get the point. So let's say applications. So let's put IoT there. I wish I had a refrigerator. That'd be even better in this section. All right, so there we go. And then VLAN 4, let's just say this one is guest network. There you go. It's a guest. So that's the last one. So that's pretty common as well, right? So normal home setup is you will always have like a basic default network, and then you usually have, and I was gonna say always, but it's probably just usually have with the ISP rental router slash modems, you'll have the option to activate a guest network. I know in my experience, pretty much all the devices have those options. So there you go. So that's what we're going to do our network. So it'll be VLAN, which is default, VLAN 1, IoT, mobile, and guest. Okay. My names will vary a little bit, but for the concept, that's what we're covering. So what does this actually look like when it comes to setting up your device? Well, I guess I can. Let's do this. Now that we have the idea of it being separate, I think it'd be a good time to jump into my application, which is the Unifi OS, and show you a front view of the switches that I use and what they look like. Okay, and the reason why I'm doing that is because it'd be a little easier to get an idea as to how you can actually do the VLAN implementation. All right, so let's jump into that. So here we are on the interface of Unifi OS, and I always say UDMP, but it is the OS Unifi. So we're going to first click on network, which is right here, or the tab at the top. It doesn't make a difference. Please ignore my IP address. That will be blanked out. And port management. Okay, so I guess first, let's show my devices. Okay, so here we have it. This is a listing of all the devices I have on my router. Well, let me say my network, right? Because the home router slash modem I use, I also have connected an additional switch and a Wi-Fi access point. In addition to it's not a repeater. I can't remember the name off the top of my head, but it pretty much does the job of a repeater, where it amplifies the signal throughout my house. So those are 4 different devices I have, and they're all Unifi products. I went that route because of compatibility and to ensure that I had no issues when setting up my gear. Now, you can always swap things out and see how it holds up. I've just read reviews where it wasn't the best in that experience. All right. So here we go. We're going to click on this one. This is my switch. I think it'd be best to use the port manager from here. All right. And we're just going to pause for a moment. We'll be right back. All right, as I stated before, this is going to be a great view to take into account what we're actually doing when we set up VLANs. Now on the screen here, I've opened up my switch, which is a 16 port switch with 8 of those ports allowing for PoE, which is power over Ethernet. Now, of course, the reason for that is we have the Wi-Fi access point. As you see here, the indicator of PoE is a lightning bolt, and it points up and gives you the title of what the device is. Now, the reason why I like doing this view is because when it comes to VLANs, it actually is not too uncommon to segment the ports on the interface to go to different components in each of the VLANs. Now, of course, I would be remiss not to mention the fact that we're considering that people have hardwired or Ethernet cables plugged into devices, and we all know that most of us use Wi-Fi. Now, it does not matter when it comes to setting up VLANs whether you're using Wi-Fi or Ethernet. It's just that the port management screen here will allow me to show you the segments you can do. But of course, if you have Wi-Fi, it really doesn't make a difference anyway. You'll never really, nothing's connected, right? So it's just all what they call logical at that point. It's just knowing that it's segmented and knowing that it works in a particular way, okay? All right, so let's say you are hardwired, and just for instance, port number 3. So port number 1, let's first look at what it is. So as you see here, this is name, just the default name, which is port 1. And then you have the default network, which is, as I stated before, for us, is 192.168.1. Now, if I want to go over to 3, this one is also the same default network, but you see it's grayed out because nothing is plugged in there. If I wanted to change, because like I stated, I already have a number of VLANs I'll show you how to set up, but I can select which VLAN goes to this port, and it can be different from this port. So that's the beauty of logical design, where it is not physical components. It's just that you're creating a virtual space actually on each of these ports so they can all act independent of each other when it comes to which network traffic it will accept. So the port 1 will not accept the same traffic as port 3 if I select, for instance, dot 4 and apply the changes. I'm not going to do that today because I haven't decided to plug anything in there, and I just don't want to be confused in the future or have to check this diagram to know what network is assigned to that port or what VLAN is assigned to that port. All right, so that being said, we have my other devices up here. One other thing to point out is you'll notice that I have two ports pointing to my NAS. So they look different. They're different connectors. So this is a 10 gig connector, and this is a standard, I want to say 2.5 gig is what came on the box. It might be a 1 gig, but I think it's 2.5. So they show up differently. The reason why I still have to figure out how to fix this, it's not getting the full gigabyte speed. It's only doing 100 megabytes per second speed, which is fast Ethernet over port 9, which is funny because the card is a 10 gig. So if anyone knows how to fix that, let me know. But I'll be doing some research on how to get that resolved as well. Now, I do know none of these ports on this particular switch support 10 gig, but I should get at least a gig, if not the 2.5. I do know that much. But for whatever reason, it's not working that way. All right, so back to what we were talking about. So the reason why I'm pointing this out is because there's something called STP, which is Spanning Tree Protocol, and also RSTP, which is Rapid Spanning Tree Protocol. Both these protocols allow us to do this one thing I'm showing now. Connect two ports on one device to two ports on the switch. So what does this do? It pretty much, you gotta look at it this way. You have one cable going in from the device into the switch, another cable going into the device from the, going into the switch from the device. And so you have two cables, and if they're both active, they're sending data to the same point, the device itself, from the same source, which is the switch, and it creates this looping effect, right? Well, what STP and RSTP do, they really increase the intelligence of the switch and says, hey, don't worry about running both at the same time. You only need one to communicate the data, and choose the one that's best at the time. Then that allows for what we call redundancy if the one cable falls out or if it stops working. So basically, instead of using both, creating a loop, it will use one, and this one will be on standby. If this one ever breaks, it will start picking up the same data. So that's the importance of activating STP. It's up to you which one you would like to do. Google the difference between STP and RSTP and see if it fits what you're looking for. And in fact, if you don't plan on having multiple ports from the same device connected to the same switch, then I wouldn't worry about it at all. As I showed you, I do have multiple ports on my NAS connected to one switch, so I do need to have this enabled if I want to first leverage the redundancy aspect of it, which is a security concept, and also just to ensure that there's not a loop being created when I have both plugged in. But that's pretty much it. All right, so let's jump into the actual networks themselves, and we'll start looking at how I configured. I added a VLAN in, and then how I configured the firewall rules so that the VLANs cannot speak to each other. Let's go and do that now. So quick note, we're about to switch over to the walkthrough portion. If you don't have the same device or a similar device under the Ubiquiti Unifi OS supported platform, then really the rest of the video is not going to be much value unless you're interested in getting one, or you just want to watch and see for yourself to help someone else out, which I definitely support. Also, before you leave, just please subscribe and leave a comment. I really do look at the comments. I try my best to reply and take away from the comments something I can do to improve the channel. So that being said, let's go ahead and jump back into the video where we'll do the walkthrough. Thank you so much for sticking around, and let's continue the journey. All right, so from the interface, we're going to go to the network tab, and then from network tab, we'll go down to networks. And here we'll select to create a new virtual network. Now, this is going to be just a test for my system, but obviously you would name it whatever you think is best. I'm going to start with the name test. From here, I'm going to show you how you can modify the actual IP address range provided. We're just going to click on the auto scale network, and then from here you can modify the actual range of IP addresses that will be allotted. And that also entails changing the net mask. The net mask will determine how many hosts can be added to this network once it's been created. From here, let's look at, I mean, obviously we don't need to keep that on, not for most of us. We can leave it as auto scale, but just in case you want it to have a little more granular control. Now from here, we'll go down to show you the manual settings. Now within the manual settings, you'll be able to specify a DNS server. So for instance, if you're running a Pi-hole DNS sinkhole, you'll be able to specify that IP address here. And then looking at the rest of this is really just some of the basic settings that you don't have to worry about really putting into. You really don't have to worry about enabling if you don't like to. But if you like to copy what I've done, I just entered in all of my networks in the multicasting. And then for IGMP snooping, I just did the primary networks I use, which are the default, the work, and the lab. And that's just because it increases, I don't know how it works, but it supposedly increases the speed of data traveling between those networks. All right, and as I mentioned before, you have the STP, RSTP, and or disabled, which we've already gone over, and that's pretty much it for this. We've selected everything we need to select. We save it, and now the next part is to go into setting up the firewall rules so that we can ensure traffic from other VLANs are not accepted into this one. How do we get there? We go over to on the left panel, we go over to security. And we see traffic rules. We don't want to be there, but just want to show you what it looks like. Then we have port forwarding. If you have any ports you want to forward from external internet access, any ports you want to set up to be forwarded from the internet. And then we also have where we want to be, which is the firewall settings. So now in firewalls, I'm going to show you just demo what I already have existing so you see what a complete rule looks like. And this one is a drop rule. It is a LAN in, and then it is also showing the source being a network source, and then we specify the name of the network that the source traffic will come from, and then the network we want to restrict or drop all packets to. All right, so let's go ahead and set up our own. All right, so let's go ahead and create a new entry. Now this new entry, we're going to do the LAN in as the type. That's what I commonly do for my setup. It's up to you if you choose between LAN in or LAN out. Just be consistent on the type of rules you're creating. And then we select the drop, and of course we want to leave the checkbox before predefined. Now predefined rules are the ones that come with the box. And if you're not aware, the way firewall rules work is that it goes from top to bottom, which means it will always execute the first one in the list, and then if that does not apply, it goes to the next one in order. So that's why it's selected as before the predefined ones. Once we're done with that, we'll go down to the source type, leave it as network, and then specify the name, which is test in this case, and then we'll specify the network below that we want to drop the packets to, which in my case, I'm going to do the work network, which I have labeled as employer network. And then we add the rule. Simple as that. Now, if you need to, you can reorganize them and structure them accordingly, based on the preference as to which rule should be executed first. So if you want to reorganize it, it's up to you. All right, y'all, so that's it. So we finished setting up the VLAN as well as configuring the firewall rule so that we can block traffic between our multiple VLANs and really ensure the security of our network. Well, I appreciate it. Once again, thank you so much for tuning in today. So if you missed it before, let me just reiterate. The next video is going to be on restricting access to the management portal, which is what we're looking at here, and ensuring that only one VLAN, our default VLAN, can reach this. Because as we know, we created multiple VLANs, which means that each of these VLANs have their own path to the same management portal. So tune in for the next video to learn how to restrict that and really lock down your settings. Make sure you subscribe, you comment, share, and also like if you enjoy this content. See you next time. Let's continue the journey together. Bye.